So in this lesson, part of the lesson 7.1, we're going to talk about analyzing quantitative data. Now, these are just going to be descriptive statistics that we'll be focusing on. We'll talk about doing inferential statistics in the next section. Now, when we're describing nominal data, research obtained nominal data when they classify participants by names or words instead of quantities. So, for example, if you want to identify females as 1 and women or men as 0, there isn't a one more difference between the men and or the females and the males. It's just that that's a way to then quantify them in statistical analysis. Now, the most common descriptive statistics used for nominal data are frequencies and percentages. And here's a table derived from a previous class in research methods. And you can see that here's an example of the percentages of females and males. And here's the major concentrations in terms of the exercise and sports psychology and the exercise physiology. And what you'll notice here is you really can't derive any particular inference from this in terms of saying that just because there's more exercise physiology students versus psychology students, that somehow the exercise physiology students are more interested in this class, when in fact it could just simply be the differences in the way the program is laid out and the emphasis on the major requirements, and that could be the case. Now, you could infer a little bit with the females that there might be more interest in the females, but again, and taking this class, but again, it could just simply be because more females are part of the graduate program at this time, and it can fluctuate from year to year. Now, here is a nominal data in terms of an output from SPSS, and we're going to watch a video that overviews how you can go about getting this frequency table, and then here is the actual graph of what this frequency table would look like.
So I'm in SPSS now. Yours might look a little different. I think the version of SPSS that is in the virtual classroom is a more recent version, but all the functionality should be the same. So I go to Analyze, Descriptive Statistics, and I want to calculate frequencies, and that's it. And I want to get, and I've already done this, so I'm going to back up so you can see how I input these things. So I just want to know the breakdown of males and females in our sample data set. So I enter that over into my variables window. This is always clicked by default. We do want that frequency table. Any statistics? Well, right now I don't want them, but for future reference, you can calculate mean, median, mode, sum, standard deviations, all of those things, even your interquartile ranges, which I'll show you later, are all here in the descriptive statistics option for SPSS. But right now, obviously, it wouldn't make any difference, or it would not make sense to calculate the mean for gender, because you can't have 1.5 females to half a male, you know what I'm saying? So we're going to skip this. I could chart this. So let's say I want bar charts that I would like to put into some presentation, and I can do either frequencies or percentages. I chose percentages as my display in the table, and now it's ready to go. I mean, there's nothing else I really need to change, so I'm going to go ahead and click that, and you see here's my frequency table. It gives me my frequency for males and females, what percentage, and the valid percent is if I had any missing data, but I don't have any missing data in my fake data set. So, and then here's the bar chart for gender for females and males that you could use to present this information visually if you wanted to. Okay.
So that was just an overview, a video of how to calculate this nominal data using SPSS. Now, what about analyzing nominal data? When researchers want to test a null hypothesis related to differences between frequencies, in other words, the number of cases on a single variable, a univariate chi-square test is used. And you can see here is going to be the alternative hypothesis and the null hypothesis. And keep in mind that consumers of research should be most concerned with the p-value reported in a research report. So here is a table of the data in terms of superintendent's approval of increasing physical activity requirements for high school students. So here is a frequency in terms of the yes response and in terms of the no response. And you want to determine, is there a difference in other words, is the null hypothesis, the categories defined by approve or disapprove of the policy a change. So you're trying to find out, is there really a significant difference between those who approve of the difference of increasing physical activity versus those who do not? And so this is a nice output from SPSS that gives you an idea of what it would look like. And so it does a nice null hypothesis. It actually does the binomial test. It does the significance. You can see that it's less than 0.05. And here's again the significance level that was set. And it does a nice job of actually indicating the decision. So you would reject the null hypothesis, indicating that there really is a difference between the two responses, yes versus no.
Univariate chi-square test, we go to analyze. We're going to go to, I think we'll probably want to do this with a non-parametrics test, one sample. And I don't know why that pops up in the other window. I'll pull it back over. And I'm going to leave this at the default setting of automatically compare observed data to hypothesized. It's to hypothesized values is what it would say. Fields, right now everything is in the test field, and I don't want to test all of those different things. I just want to see if there's a significant difference in the number of approve or disapprove votes. So I go to custom field assignments. I click on this variable and move it over to the test fields. Looks good. Settings I'm going to leave alone because it's going to automatically run the chi-square test for me. And now I can go ahead and run that. And there we go. There's my output. It just basically tested whether or not there's a significant difference in yes and no votes for me. And this is what I put into the PowerPoint slide, as you saw.
So again, that was just a video of how to use SPSS to determine this nominal data using a univariate or a single variable. So what about when researchers want to test a null hypothesis related to differences between frequencies when participants are classified according to two variables, a bivariate chi-square? So for example, let's say you have an alternative hypothesis where female superintendents will be more likely to approve of increasing physical activity requirements for high school students, and your null hypothesis is there is no relationship between gender approval of increasing physical activity requirements. And so here you would have a table from SPSS that would be generated, and then you're doing a gender. Does it vary the gender? Does that dictate or affect the approval or disapproval of the policy change? And here's the count for females that said no, those that said yes, and here's a total. And here is the males in terms of said no and versus yes. And this expected count just means that it indicates your total should indicate that's the percentages, and they should hopefully equal the expected count, and the actual count hopefully will equal, indicating there's no missing data. And then here's the actual total between the two. And what we do is we actually use the Kramer's V, which is just a way to determine if there was a significance in this using this chi-square. It's not important for this class why Kramer's V, but just know that here you can see that the approximate significant level is 0.091, so it was greater than 0.05. So in this case, you would fail to reject the null hypothesis. In other words, it's still an option. So by rejecting it, it indicates that there really, at this point, there is no relationship between the gender and approval of increasing, so you fail to reject that. So it doesn't matter whether you're males or females in terms of your feelings about approving or disapproving of the policy change. Again, you want to, as a consumer of the research, you should be most concerned about with the p-value reported in the research report. So now let's take a moment to see how this was calculated using SPSS.
Go up to analyze, and again what we're interested in is we're going to look and see if this approval or disapproval of this new policy differs significantly by gender. So are males or females more likely to approve or disapprove of this. And so the way we're going to do this is go to Analyze, and we're going to go to Descriptive Statistics, to Crosstabs, and now I'm going to put gender in the rows box, and I'm going to put approve or disapprove in the columns box. And then for statistics, I want to choose chi-square, and you have to trust me that we'll just go with define Kramer's V, because they're both nominal variables. One of them, they're both basically dichotomized as 0 and 1, so we're going to pick that. And for sales, we want the observed, and we'll go ahead and look at what expected values are. Continue, and we can go ahead and hit OK now. And here's what you'll see: your gender times approve or disapprove of the policy. We have a complete data set because it's fake. That's always a good thing to have no missing data. It does happen sometimes that you have missing data, and this is our basically our 2x2 table, and it's broken down by gender and broken down by whether they approve or disapprove. And that's the one that I copied and pasted into the PowerPoint slide. One thing that we want to look at here is we can look at the Pearson chi-square, and that's just a basic chi-square test when we're not indicating what types of variables we have. And you can see that our significance is 0.09, so we do not have a significant difference here, and it's actually the same for the nominal by nominal analysis down here at the bottom was 0.091 as well. And this was the one that, technically we would want to report on the Kramer's V for nominal by nominal variable or analysis, sorry. So that's just simply how you would do a 2x2 table, a chi-square test for when you have people categorized by more than one variable. So in this case, it was gender and whether they approve or disapprove. And we don't have a significant difference in our data set on that.
So that was just a video overview of the analyzing nominal data. So what about shapes of distributions? Some people are visual and it's easier for them to see things. So researchers can also describe their data using a frequency polygon, which can allow for visualization of how data are distributed throughout the sample. So here's an example of a distribution of the data, and this is the normal curve. You may have heard of the normal bell curve, for example. And what it reports is the mean, median, mode, which we'll go over in a little bit, are all in the middle of the bell curve. Now, negatively skewed curves that you see here indicate most values are high. So most values are high, and they fall to the right of the simple mean. So they're going to be pulling the mean or pull the data to the right in terms of to the right of the mean itself. Whereas you have the positively skewed curves indicate most values are lower and fall to the left of the mean. So here we have most of the data is to the left. But the idea is that you can see the difference between a negatively skewed and a positively skewed. Now, normal bell curves mean that values are evenly distributed around the mean, as you would expect. So here is a table that we're going to show in just a moment of how this can be actually calculated in SPSS. And this is the minutes per week of moderate physical activity. So here we have mean, and here's the standard deviation, and here's the sample size. So let's take a moment to show how this was calculated using SPSS.
So for this, you can go up here to Graphs and hit Chart Builder. And I did a histogram type where it basically shades in the area underneath the curve. And so I'm going to click on that, and then I just drag this, it's a line, basically it's a histogram chart, but it uses lines. So it would be similar to the line chart here, but I'm going to do it as a histogram. I'm going to drag and drop that in here. And now the only thing I was interested in this sample analysis was the minutes per week of moderate to vigorous physical activity. So I'm going to highlight that variable and just left click and drag it over, drop it in there, and you see my little distribution there. And excuse me, I want to display the normal curve. And so I apply, and you'll see the normal curve there, and it looks pretty good. I could if I wanted to, and I don't have to, but you can go in and set the parameters, and you could say, you know what, it wouldn't, people can't have negative physical activity, so I could say my anchor is 0, continue, apply that, and then hit OK, and you'll see how that looks a little bit different than, or actually this is exactly how I did it, but that looks a little bit different than our, if we were to include negative values. So if our anchor changes, our distribution is going to look a little bit more skewed. So we do have, and you can even visually see, here's our mean is 92. So somewhere around the tip of this curve is our mean. But we have this humongous standard deviation, so that basically 68% of our scores are falling between 0 and 180 something minutes of physical activity. And then we have these extreme measures up here of people who are doing 360 minutes of physical activity a week, and that is pulling our mean over somewhat. So that's just an example of how we can create a frequency polygon to visually analyze our data as well.
So this is just an overview, or that was an overview of how you can use SPSS to calculate these distribution curves. Now there are other things to report, mean, median, and mode, and what do those mean? You may have heard of them before, but researchers most often report the mean for the data, which is the sum of the values divided by the number of values as the average. And the mean for a population is often reported as a capital M, whereas the mean for a sample from the population is reported as a lower M. Most likely you'll see lower M because usually you don't see an entire population reported. Now, a drawback of the mean is that it's pulled in the direction of extreme scores, as we saw before. Now, when a distribution is highly skewed, then the median middle score can be reported to give a more representative average value. And you most likely will see median and mean reported together. Seldom do you see, though, the mode is actually going to be reported, and it's not very frequently occurred, but really it's used to report the most frequently occurring value in your data set. Now, often accompanying the mean in research reports is the standard deviation, which is denoted as a capital SD for population and for a smaller SD for samples. And the standard deviation is used to describe the variability in the data. So how much does it vary around the mean itself? And variability refers to the amount participants vary or differ from each other. So if all the values obtained from the sample are the same, such as let's say you were to survey all the people in this class to how many minutes of physical activity you get in a week, and they all said 150, well, the variability would be 0, or the standard deviation would be 0. Well, that's highly unlikely that you would get a variability of 0. But again, the smaller the standard deviation, generally speaking, the better, because it indicates that you have not much deviation from your sample. And usually the larger your sample size, usually your smaller your standard deviation will be. Now, standard deviation is closely related to the shape of a normal curve and the frequency polygon. So here is an example. If a distribution is normal, as seen in the polygon here to the right, obtained from our example data set that we've used previously, then that would mean that 68% of the values obtained in the data set lie within one standard deviation of the mean. So in other words, here's our data set, and it tends to be evenly distributed. And what we see up here is we have a mean of 35.6 and a standard deviation of 3.4, and here's our sample size. And what this would mean is that based on the polygon here, a consumer research could conclude that 68% of the participants' BMI scores lie between 32 and 39. So how do we get this? You simply take the mean, and then you would add, or you subtract the standard deviation of 3.4, and that would get you 32.2. And then you would add the 3.4 to the mean, and you would get 39. Well, you might see this reported in the literature as the mean BMI in the sample was 35.6 with a standard deviation equals 3.4. Or you might see it reported as 35.6 plus or minus 3.4. But either way, this is an example of how you can report mean and standard deviation. So another variable to report is the median or the middle score, and it always has 50% of scores below it and 50% above it. Now, the median is important to report is when the distribution is highly skewed or when reporting an ordinal rank scale. So we talked about the highly scale when it's maybe positively or negatively skewed, showing a median might be effective in doing that. Or you can report an ordinal scale. Let's say you have a Likert scale ranging from 1 to 5 in terms of health status, 1 being low, 5 being high. Well, if you have a doing a mean score of, let's say, 3.8, well, that doesn't give you any idea of what that is meaning. And how much more is it than, let's say, 3.6? So using a median score, let's say 3 or 4, would give you a little bit better when you're using, let's say, a Likert scale. Now, it's also customary to report the interquartile range, represented as IQR, with the median. And the range is the highest value minus the lowest value for IQR. And it ranges in the middle 50% of the participants. So you're really going to be reporting the 25th to 75th percentile. Now, the mean and interquartile range can be calculated using SPSS. It could be hand calculated by hand if it's a small sample set, but most likely you're going to be using a statistical software. Now, the output to the right identifies the median, as you see here, the median of 60, as well as the cutoff for the 25th percentile. Okay, the quartiles percentiles are the same. Percentiles and quartile in this case are the same. But here is the median of 50%, and here is the 25th percentile and the 75th percentile. And you can report this. So you can report this as a median of 60, so a median of 60. And the IQR would simply be the 75th percentile minus the 25th percentile, or 150 minus 30, and so your IQR would be 120. And these were reported simply by, in the literature, as the median minutes per week spent in the MVP was 60 with a IQR of 120. So the idea is that using the IQR, it gives you a broader view of where the majority of the data would fall. So let's look at a video here, a short video of how this can be calculated.
I go to Analyze, I go to Descriptive Statistics, Frequencies, and it was for minutes per week of MVPA. Go to Stats, and I'm going to go ahead and say, give me the mean, give me the median, give me the standard deviation, give me the quartiles, and now I should be good. And I'm going to get a lot of different output here, but you can see I get my mean, I get my median, I get my huge standard deviation, which tells me that that's probably, the mean might not be a good one to report. But here's my percentiles. The 25th percentile, 30 minutes per week, it was the cutoff, and then for the 75th, 150 minutes per week was. And so I just subtract 30 from 150 to get my interquartile range for the median of 60. So pretty simple way of doing it. I did not mean to graph it, but it is graphed there if you wanted to. So that's a simple way of calculating the mean, median, interquartile range, standard deviation, and all those things, just using descriptive statistics function or frequency function in the Analyze tab.
All right, so that was an overview of how to calculate the median and entire interquartile range along with the mode and mean. So this concludes this part of the 7.1 using descriptive statistics. Make sure you have a good understanding of this, and then we'll move on now to inferential statistics.